All engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to the show where we bring you the latest breakthroughs in science, technology and medicine with me, Chris Smith.
and me, Eva Higginbotham. Coming up, the fireball that shot across the UK night sky, a new device protects women from HIV, and the carbon footprint of cultivating cannabis.
Plus, solving the mysteries of ancient Egypt. We delve into the discovery of secret chambers hidden inside the pyramids, and do glowing bones reveal antibiotic use was going on thousands of years ago.
The Naked Scientists podcast is powered by ukfast.co.uk.
On the final day of February, people in some parts of the UK were treated to a celestial light show as a meteor streaked in from space. Hundreds of videos of the fireball have since been posted online by amateur photographers.
What's even more special is that by analysing the footage caught on multiple networks of cameras, for the first time in 3 decades in the UK, the culprit, and as it turns out very rare, space rock that caused all this was successfully tracked down and recovered from someone's driveway. Phil Sansom spoke to the UK Meteor Observation Network's Mary McIntyre to hear how it happened.
There was a really bright fireball picked up across multiple networks a week ago on Sunday. And later in the week, we found out that a meteorite had in fact been recovered. And this is an incredibly rare thing to happen in the UK, actually even in the world. To recover a meteorite that's been seen as a fireball is quite rare. Then we found out that it's one of an extremely rare kind of meteorite, so it's just so many special things, and we've all just haven't been able to sleep because we're just so excited, and such a huge win for citizen science. It really was.
Wow, and you didn't even know it was coming, did you? It just sort of appeared as a flash, right?
Yeah, these things, you can't predict them. They're entirely random pieces of space debris. And this one was really unusual because it was captured by so many cameras across the UK because we had a clear sky across the country.
What does it look like? Is it just a bright, the whole sky lights up, or is there like an angle you can see and that's how you figure out where it's going?
It depends where you see it from. So our camera, so it was heading straight for us. So actually on our camera, there was just an enormous flash and it was really difficult to get any data from it because you couldn't see a flight path. But there's a guy called Richard Fleet down in Wiltshire who caught it side on, and it is the most phenomenal kind of bright thing streaking across the sky that just resulted in this enormous kind of explosion, and it fragmented. We could see that there were multiple fragments there. And once you kind of do the calculations behind the scenes, they can figure out the speed it was moving, the angle through the atmosphere, its exact path before it burnt up. And once you do all of that, they can also figure out the mass. And once you know the mass, you can then calculate whether something may have survived and landed. Now, normally something like that would be kind of kept quiet for fear of contamination. But because of COVID and the fact that the area that they think it landed in was basically lots of farmland in the Cotswolds, none of us actually thought for a second that this would get recovered. And if it was recovered, not for many days when it had been rained on and all of that stuff. So it was just incredible.
It could have gone in a stream, I'm guessing. It could have gone in, I don't know, a sheep's trough and sheep ate it.
Well, many fireballs in the UK are thought to survive, but they end up in the sea because the UK is quite a small island.
So who actually found it and how?
One of the homeowners had actually heard a thud on their drive the previous night
You're
while they were in the
joking.
house, and they just didn't think anything of it. But once the Natural History Museum put out a video to locals saying, if you see anything, please have a look. And they went out and there was a fragment and some dust and kind of black rays on their driveway, and I think a fragment had bounced over the wall to next door's garden. Once people arrived on the scene from Wednesday onwards, there was like a fingertip search of the area and more fragments have been found, and we've now found about 400 grams of this, which is just extraordinary.
You said that not only was it, amazing space rock, it's also a very special kind of space rock?
It is. It's a type of meteorite called a carbonaceous chondrite, and they're really important because most of them originate from the asteroid belt. And I mean, asteroids themselves are really old because they're leftover material from when the solar system formed 4.5 billion years ago. But what's amazing about carbonaceous chondrites is they have these tiny little spheres of material that actually predates our solar system. Some of them have organic materials like amino acids in them. And to get a sample that is really pristine like this is incredibly rare and so important for scientists to kind of analyze the material and find out the origins of our solar system and before our solar system. It's just been one of the most amazing stories of the decade. And there hasn't been a full that's been found for 30 years in the UK. So
Wow.
it's amazing.
And what's funny as well is, aren't there missions going on right now sending probes up to asteroids way out in space, desperate to try and get any sort of sample from them? And we've just had one land right at our doorstep.
It is. Well, there was actually a mission to the asteroid Ryugu, and the quality of this sample is comparable with that sample return mission from Ryugu. And they brought back like tiny amounts of the asteroid, and we've now got 400 grams of this. I mean, you can't rely on them landing as a way of analyzing them because it just doesn't happen very often. I mean, meteorites are found all the time, but they've been led on the ground for who knows how long. And I still can't quite believe it's real. Honestly, when I found out, I just cried because it's
Oh,
such an amazing story.
wow.
Astronomy gets me like that.
Bet the homeowners were glad they didn't leave their car in the drive that night, weren't they? That was a very emotional Mary McIntyre. She's from the UK Meteor Observation Network, and if that story has piqued your interest, you can get in touch with that group, look them up online, and they'll tell you how you can set up your own meteor camera, and then who knows, maybe you'll be catching the next amazing bit of space dust raining in.
Now, around the world, close to 40 million people are living with HIV, most of them in poorer countries. But encouraging results from a drug-impregnated ring that's inserted into the female genital tract show that it can cut HIV infection rates by 50%.
It's a staggering difference, isn't it? It's made of a soft silica material, which is designed to remain in place for up to 90 days at a time, and then steadily, as it goes along, release a cargo of the anti-AIDS drug, dapiravine. Now, this could make a very big difference to the autonomy of women who live in third world countries, which have been previously very hard hit by HIV. Public health researcher Albert Liu has just presented the latest performance results of the ring at a conference.
Women make up more than half of all people living with HIV, and they need a range of strategies to prevent HIV infections. One promising approach to HIV prevention is the use of vaginal rings, which are really exciting because they offer long-acting prevention approach to preventing HIV.
Now, when you said that women make up more than half of cases, why are they disproportionately impacted by HIV then?
In sub-Saharan Africa, it may be unequal relationships with men, as well as some women engage in sex work and may have less economic opportunities. And there may also be some biological differences that make women more susceptible to HIV.
And the approach that you're testing here, tell us how it actually works then. What does it do and how does it protect the user?
The vaginal ring that we have been studying was developed by the nonprofit group, the International Partnership for Microbicides. They've developed a ring that contains a medication called dapivirine. It's an anti-HIV medication that is dispersed into the ring and releases the drug slowly into the vagina. This medication prevents infection taking place in the body.
And does it actually work? Is that what you're finding?
There were two large studies in over 4,500 women in Africa, and they found that the ring was both safe and effective in reducing HIV infections. The latest studies that were done suggest that the ring reduced HIV infections by about 50%.
Why is this better, though, than just popping a pill? Because we could give this same drug in pill form, which arguably might be even easier to distribute.
Yes, the pill form of prevention, also known as PrEP or pre-exposure prophylaxis, is a really important and exciting option for HIV prevention. But what we've seen across a number of studies is that oral PrEP is not for everyone. There may be a number of reasons why women may prefer not to take a daily pill. It can be challenging for people to remember to take the pill every day. Also, the pills needs to be kept private. That can sometimes be a challenge. So there needs to be a range of options for women to be able to choose different options that will work the best for them.
And is the strategy then that the women insert these rings and keep them inside for the full lifetime of that ring, or do they take it in and put it out on a daily basis? How does it work?
The ring is designed to be inserted and remain in place for the duration of use. And so for the monthly ring, that's for the whole monthly period.
You've got a ring here which has got just one drug in it. Is that not a risk, though, that we're going to end up with the next scourge of HIV being resistant to that drug, and it will just therefore surmount the protection conferred by these rings, and people are going to catch HIV anyway?
That was looked at in several of the earlier studies. They looked at women who became HIV positive in the studies, and they did not see development of HIV resistance as a result of use of the ring.
How is this going down with the users?
Women have reported that the ring is very easy to use, and also neither they nor their partners could feel the ring during sex, and they liked this option as a prevention strategy.
And impact on fertility? Is there any impact on likelihood of conception? Are these drugs considered completely safe if a person does fall pregnant while they are using this particular method?
There isn't evidence that these rings affect fertility. We are currently doing a study of ring use during pregnancy, and a really important study because women during pregnancy are particularly vulnerable to acquiring HIV.
Albert Liu from the San Francisco Department of Public Health.
The world is worried about a number of new coronavirus variants. But are they going to be a problem for the vaccine? Biologist Pei-Yong Shi is working on exactly that.
We think the vaccine still works quite well.
Here's the issue: quite well sometimes means not as well, and we don't know whether that is good enough.
That minimum bar has not been defined.
That and more on February's episode of Naked Genetics, wherever you get your podcasts.
Coming up, the carbon footprint of cannabis production and unravelling how novel technologies are helping scientists uncover the secrets of ancient Egypt.
But first, though, researchers using the Large Hadron Collider, the LHC at CERN, say they've recently discovered a new exotic form of subatomic particles called tetraquarks. They exist for just fractions of a second, so they're very hard to spot. They're even harder to study. But luckily, with us now is the University of Cambridge's Harry Cliff. He's a physicist working on the experiment that discovered them, and he does, I'm pleased to say, Harry, have slightly longer to tell us about them than they hang around for. What's a tetraquark, then?
Very simply, a tetraquark is a particle made of two quarks and two antiquarks, so sort of four objects inside it, basically, hence the tetra. It probably requires a bit of unpacking, though, because, well, you might ask, what's a quark? Well, every atom has a nucleus, and you probably know that the nucleus is made of protons and neutrons, and we've known for more than half a century now that protons and neutrons are made of three quarks each bound together. Until recently, we only knew of combinations of quarks that came in threes or in pairs. So tetraquarks are a whole new class of particle that we didn't know about until relatively recently.
It's funny, isn't it? Because the reason we call atoms atoms is the Greek word tomos means cut, and atomos means can't be cut down further. So initially, scientists thought atoms were the smallest possible things, and then people realised that atoms have got things inside them, protons and neutrons, and thought they were the smallest things. And then people like you started smashing things together at very high energies and realised that those tiny things inside atoms have actually got tiny things inside those. Those are the quarks.
Yeah, that's exactly right. I mean, there was this big mystery in the 1940s and 50s when in particle colliders and in astrophysics experiments, people were discovering all these new subatomic particles with all strange names. They're all usually with kind of Greek letters like omegas and deltas and lambdas. And it was called the particle zoo. No one really understood what these particles were. And it was eventually realized you could explain this huge number of different particles as being combinations of basically 6 different types of even smaller particles called quarks. So that's our most up-to-date understanding of the basic ingredients of matter today.
Why don't these things hang around for very long, though?
Basically, it's to do with the forces that bind them together. So actually, there's only one particle made of quarks that's, as far as we know, completely stable, and that's the proton. So that's the thing that's inside every atom. And that is a good thing that the proton's stable, because if it wasn't, well, every atom would disintegrate. But anything apart from the proton basically is unstable. It can always collapse, and it either sort of break apart or annihilate with itself and turn into other particles. So these things, because they're bound together, but not in a way that allows them to exist for any length of time, and they very quickly disintegrate into other sets of particles, which we then detect in our experiments.
Are they therefore a real and important part of physics, or do you think they're just an artifact of the fact that you have, in an unnatural way, slammed particles together? You can detect these things transiently, but because they disappear, they play no part in genuine physics? Or do you think they really do have a role to play in the way that the universe works?
Well, they tell us something about one of the four forces of nature. So we know about four forces: gravity, the electromagnetic force, something called the weak force, and the strong force. And the strong force is the force that holds the nucleus together, holds quarks together. But the strong force is really mysterious. Despite being, a force we've known about for ages, it's really hard to understand, and it's very hard to make predictions using our theory of the strong force. So we can't really work out in advance how quarks come together and what combinations are allowed and which ones aren't allowed. So discovering new particles like these tetraquarks tells us something about the way this strong force interacts. And as one of the sort of four basic forces in nature, that's a really important thing to get a deeper understanding of, and has impacts on the rest of our understanding of particle physics as well.
And hopefully that's going to keep you busy for a little while and you're on the case. Thanks very much, Harry. That's Harry Cliff, a physicist at the University of Cambridge.
You can see why it was called the particle zoo, quarks and quacks and all sorts. Now, although the use, sale and possession of cannabis is still illegal in the USA at a countrywide level, in 2012, the states of Colorado and Washington became the first to legalise it for recreational use. And by the end of last year, 12 more states had followed suit, with 36 states having legalised it for medicinal purposes at least. This has taken what was an underground black market of cannabis production into the mainstream, with legal cannabis sales projected to reach $22 billion by next year.
It's a lot, isn't it? But cultivating cannabis on this sort of scale is very energy intensive. The plants are grown indoors using very powerful light, and they also pump in additional CO2 to maximise the yields. Well, all this got Colorado State University researcher Hayley Summers wondering about the potential carbon footprint of all of this homegrown produce.
It's a windowless warehouse. The smell hits you right away. And there's just a canopy of green. And then you've got these really high intensity lights that almost feel like you're getting a sunburn inside. And then there's a suite of dehumidifiers around the room. And there's usually simple office fans mounted to the walls that are circulating air. And then there's a number of climate control systems on the wall, because most growers really care about the environment that these plants are being grown in. And so they control it heavily to make the best product possible. In our study, the primary intent was to quantify the greenhouse gas emissions from growing cannabis plants indoors.
Why would someone choose to grow cannabis indoors where they have to provide things like light, as opposed to growing it outdoors when the sun's just there?
Yeah, there's a number of reasons. A big one is being able to control the product. When you grow artificially indoors, you can keep your indoor climate, your temperatures and your humidities very regulated. And so that allows you to make the best product possible. There's also some security or theft issues. An indoor warehouse is a very secure environment. Also, it allows you to get multiple harvests per year. Because you can create an artificial environment and grow year round, you're not limited to just the weather outside, right? If we were to grow cannabis outdoors in Colorado, for example, purely outdoors, we would probably only be able to achieve one harvest per year. Whereas indoors, you can get about 6 harvests per year.
What kind of factors did you have to consider?
So we investigated 2 primary inputs, and that would be your energy inputs and then any material inputs needed. The energy inputs primarily break down to either electricity or natural gas. And then the material inputs we considered include things like water or fertilizers or carbon dioxide. And so we looked at basically all of the quantities of those inputs needed, and then we equated those inputs to greenhouse gas emissions using a standard methodology called life cycle assessment.
And what did you find?
The total amount of greenhouse gas emissions was pretty significant. So we analyzed over 1,000 locations across the US, and we accounted for variations in weather and electric grid mix. And so those play a pretty big role in determining your overall greenhouse gas emissions. In Colorado, we were able to obtain the amount of cannabis being produced, and that translates to about 1.7% of Colorado's annual greenhouse gas emissions.
How big of an impact is this intensive growing of cannabis having in comparison to other industries that we know release a lot of greenhouse gases too?
In the past few years, a previous study came out and said that about 4% of Denver's electricity is coming straight from these grow facilities. So that's a pretty big portion of our electricity use. And to put this into context, there's a couple other sectors that I can compare that to. One would be coal mining operations. Those in the state of Colorado are about 1.5% of the state's annual total, so a little bit less.
If we just switched to renewable energy resources, which is hopefully on the horizon in lots of parts of the world coming up, would we solve the problem of this energy-intensive farming?
I think that growing indoors in the state that we are is probably the worst it will be. As we clean up the grid, it's certainly going to help, but there's still some of these material inputs, such as the carbon dioxide supply, that are not directly associated to the grid.
If it's so hard to grow cannabis in Colorado where it is cold, why don't we just grow it all outside in California where the weather is ideal for growing cannabis?
So there's a couple reasons why we can't do that in the current state. The biggest one is legalization. So currently for states that are either medicinally or recreationally legalized, you would have to grow that cannabis in the state that it's legal in. So right now we can't grow in a state and then transport across state lines. If federal legalization was to lift, we could probably come up with a centralized location to grow the majority of cannabis and then distribute from there.
Food for thought, eh? Hayley Summers there, and her study was just published in the journal Nature Sustainability. Now, to slugs, and a new video game simulation is being published by a company called Slug Disco. It models the evolution of life in a realistic underwater world. You put basic starting creatures into this water, and then you create the environment in which they're going to live. You then watch as they evolve and adapt to their environment and to each other, just as Darwin described. It's called Ecosystem, and the Naked Gaming podcast's Chris Sparrow caught up with creator Tom Johnson.
The game was kind of inspired by some research that was done in the 90s at MIT by a guy named Carl Sims. He was sort of working with virtual evolution. The idea is that you kind of have these creatures that are actually a bunch of boxes jointed together, basically, and they have virtual brains that are basically pipeline computers. So they take in like visual input, auditory input, stuff like that. They do a bunch of processes, and then as an output, they apply torques at all their various joints. So they kind of move around just like we do. So unlike a normal game, the creatures aren't necessarily playing like an animation that like an artist made. They're actually contracting joints at each joint that they have. And so the idea is that if you take a bunch of these creatures, just like totally random ones with random brains and random bodies, and you throw them in the ocean, most of them will just kind of flail around, but a few will probably get a little bit. And if you let the ones that move the furthest have the most children, then after enough generations, you will actually have creatures that can actually swim. So in that sense, it's like a true evolution game because the physiology is driven by the function. And so the premise of the game is basically that you kind of shape this environment, and then you sort of throw in these creatures and they adapt to all the different like niches that you create.
How do you model something like that? Because I know that there are existing models for evolution, but how did you actually design that into a game context? Because that strikes me as probably the most difficult thing.
Yeah, it took a lot of work. In fact, when I first started, it would actually take a full day just to get an evolution, just to get a creature that could kind of swim. It was a very sort of experimental process because it doesn't map quite cleanly to an existing game. There's not like some well-established tradition that I could kind of follow and copy, you know? So to some extent, there's a big element of creativity to it, that you kind of have this fish tank, except that the fish are morphing to your tank.
What are some of the other factors that, are at play here?
There's a couple other ones. One that I did recently was like a creature vision system. So in addition to like their physical body shape, their skin coloration and pattern and stuff like that also evolves, and it's sort of like encoded in their DNA. And so when creatures are preying on each other, they have a vision simulation. So in order to actually see a creature, if it's green against a green background, it's harder to make that out. Like, the better it fits to that, the harder that creature is to see. Because, for example, a bunch of foragers that have no predators anywhere don't actually really need camouflage. And so they may end up more like the birds of paradise, right? Because it's better for mating, right? Whereas if there's, a bunch of huge sharks swimming around looking for you, then suddenly you don't want to be the most ornate, beautiful purple fish, but you want to be the one that looks just like the dirt.
I'm presuming that if you were to, in real life, create an environment, that exactly the same thing wouldn't happen every time. Like, you might suddenly find that actually, some creatures with shiny wings or whatever would start to become very prominent. But then if you ran it again in real life, you might find that actually camouflage became the way to go just for no reason, just because that's sometimes what happens with evolution. Does that happen in the game as well? Or is it very much if you were to chuck the same thing in the same environment, it happens the same way?
There's quite a bit of variation. So I would say very much is the case that just because of random features and even how creatures are reacting to, because part of their environment is the other creatures in a sense. There's a decent chance, at least if you set the pressures just right, that you could probably get camouflage to statistically occur more frequently. One of the main goals for the game was that I wanted to sort of make sure that it could actually reproduce as much as I could, the amount of variety that you see in life. So I think I would have been a little disappointed if you always got the same handful of things. And for that reason, they often tend to come out looking like little monsters, sort of. You get a lot of very alien-looking things. But there's probably a decent chance that if you threw some microbes into the ocean in Earth, you may not necessarily get fish again. You might not get things that look exactly like the fish that we're used to.
So give it a go if you dare. Tom Johnson talking to Chris Barrow.
Now it is time for our mailbox, and this week we've had this poetic question from listener Zoe. B cells, T cells, she cells, C cells. Please explain what these cells do. Are they equally important? Chris, can you answer this for us?
Thank you, Zoe. Well, obviously this is a question very pertinent at the moment. We're hearing a lot about the immune system because of headlines around coronavirus. To put it simply, these are both types of white blood cell that are important components of your immune system. B cells make antibodies, or are involved in the production of antibodies, which are sticky molecules that go around in the bloodstream and can mop up things that shouldn't be there. And they take a while to make once you've seen a threat for the first time, and they can protect you should you re-encounter that threat into the future. T cells are a different kind of white blood cell, and they are actually in a number of categories. One are called helper cells, and they actually help to boost the response of other parts of the immune system. There are also a very important class of T cells called cytotoxic T cells, and they're programmed to go and inspect all the cells in the body as they drift around in the bloodstream and find out what those cells are doing. And if there's signs that they are harbouring a virus or producing viruses, they can nuke the cells and destroy them. So together, these things are your adaptive immune system. B cells make antibodies which can defend you against encountering a threat again in the future, and T cells can help the immune system to do what it does and also get rid of cells that are harbouring viruses right now.
Thank you, Chris. And if you'd like to get in touch with us with a comment or a question for the show, the email address is chris@thenakedscientist.com. Absy's done just that and asked us to wish Josh, who we gather is a very big fan, a very happy birthday this week. So happy birthday, Josh. Meanwhile, if you're interested in the current COVID-19 situation, you might like to listen to this week's Naked Reflections podcast, which explores the role obesity and diabetes are playing in the outbreak, and health in general, and why we need to tackle this urgently.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
For the rest of the programme, we're now going to step back in time, in fact to the time of ancient Egypt, to hear how science is solving some of the mysteries that archaeologists have been turning up over the years.
Now, ancient Egyptian civilization dates from around 3000 BC, and it lasted for almost 30 centuries, a really long time. These people made such a big impact on the landscape and on the archaeological record that the world has been fascinated ever since with the ancient pyramids, hieroglyphs, artefacts and mummies that they left behind. But many of these are wrapped up in mysteries that only now, with the help of modern science, we're beginning to solve.
And the first of those mysteries we're going to look at are the pharaohs, the kings and queens of Egypt. We've reasonably good chronological records for the later periods of ancient Egypt, but as you go farther back in time, the records get more murky. And this is made worse by the fact that new pharaohs had a habit of making their mark by demolishing the paintings and monuments of their predecessors. Tom Higham is an archaeological scientist at the University of Oxford, and he's also author of the new book, The World Before Us, How Science is Revealing a New Story of Our Human Origins. He's been involved in a project to figure all this out. Why, though, Tom, would they actually destroy what had come before? Was this really just to establish their presence or to achieve some kind of dominance?
Yes, absolutely. What we see quite often is that new pharaohs came to power by virtue of plotting or coups, and they overthrew their predecessors. And once they'd done that, in an attempt to establish their own legitimacy, they would go back and rub out evidence for their predecessors in the form of temple inscriptions, papyri, and so on. And in fact, we see this to this day. I mean, Hosni Mubarak's image and that of his wife, was systematically removed by court order in Cairo following the Arab Spring. So it's something that we see again and again.
And this presumably creates something of a puzzle, because although they wrote things down and we knew who lived when in relation to whom, if we haven't got physically things to tether to particular eras or people, it makes actually understanding that timeline that much more difficult.
Indeed, and this is part of the problem. I mean, we often think about ancient Egyptian chronologies as being absolutely precise and robust. But as you say, there are gaps in the record, and there are periods where pharaohs tried to rewrite history for themselves and eliminate the evidence for other people. And when you visit Egypt and you see the walls of temples and so on, you can see where often there has been destruction, and people have subsequently pecked out evidence for cartouches identifying different rulers and pharaohs. So as you go back in time, we have problems identifying precisely who ruled when and for how long.
How are you trying to get underneath this then and basically write history the right way rather than the wrong way that people have sought to manipulate the record?
So one thing that we can do is we can use radiocarbon dating. And radiocarbon is a method that was developed in the late 1940s. So it's a long-established tool. And it basically revolves around the fact that all of the carbon that we and all living organisms uptake has a tiny proportion of radioactive carbon, or carbon-14. And this radioactive carbon is constantly replenished until death. When an organism dies, the amount of radiocarbon slowly begins to degrade away and disappear. And what we know is the rate at which that disappearance occurs. We know that every 5,500 years, half of the amount of radiocarbon disappears. And so by measuring the remaining radiocarbon in an archaeological bone or piece of wood, we can get a date for it.
But people must have done that, given this technique is coming up for its 100th birthday, as you're saying. They must have already done that with all the artefacts we have from ancient Egypt.
Yeah, they did. But what we found was that there was a sort of mistrust of radiocarbon methods because it hadn't properly been applied in the past. Instead, people had just dated anything, really. They dated old pieces of charcoal and wood from temple complexes, which often predated the use of that wood in those complexes of temples and graves and so on. And this is a really key point in radiocarbon. We have to select good material that dates as closely as we can to the date of the archaeological event we seek to understand.
I see. So if, for instance, I wanted to know how old my wheelbarrow was, but I'd inherited it from my granddad, I would get a false date.
Indeed.
Because it's not a new
Indeed.
wheelbarrow. Whereas if you go for something which can't be inherited or can't be recycled, as it were, you potentially have got a much more fine-grained, if you'll excuse the pun, because I was thinking of things like cereal grains and things.
Yeah, absolutely. So what we did was we went back to these burial contexts that contained independent historical evidence from the Egyptian chronology. So, for example, we found evidence in the form of inscriptions on the side of a grave in which that person died during the 7th year of the reign of King Joseph, for example. And then in that grave, we would find short-lived pieces of grain and floral wreaths in the form of funerary materials and so on. Those are the things we focused on dating in order to kind of crack the problem of when these things happened in the past.
That would give you a nice, neat timeline for that murky period back in history. When you assembled that timeline, did you then discover that in fact things that we thought we understood well were in fact wrong, and we had it wrong all along?
Yeah. We didn't find in the recent period, because of the fact that we have pretty good understanding of that historical record. That was one of the things that gave us confidence that we were getting things right. But as we moved back through time, back through the Middle Kingdom, and especially into the Old Kingdom, we found that our date estimates were much earlier than we thought previously, and they were about a century earlier than previous estimates had sort of put forward. So that was quite an important conclusion to reach. Also, we found that the period before the dynastic period, the period of the Egyptian state and its formation, we found that this happened much more quickly than had happened in similar cases of state formation in places like the Middle East and Africa. And so that was also a very interesting thing because it showed that the Egyptian state began very quickly from pastoralists and people that were moving around the landscape, from a period where they then started to grow crops and to be more sedentary and live in the same place. And shortly after that, state formation happened, and we get pharaohs, we get institutions, we get writing, and so on and so forth.
Isn't science an amazing thing? Tom, thanks very much for joining us to tell us about it. That's Tom Higham from the University of Oxford.
Now, arguably, one of the most iconic legacies of ancient Egypt are the pyramids, which were built as tombs for pharaohs and other high-ranking officials, and hundreds still stand today, thousands of years later. Explorers and scientists have found their way inside many of them and uncovered rich archaeological treasure troves within. But could the ancient Egyptians have craftily concealed more inside their pyramids than we realise?
At 140 metres high and 230 metres long, one of the largest pyramids has been very well explored and studied, and the chambers inside have been thoroughly mapped out. Or so we thought, because now, using radiation streaming in from space to see through the pyramid, researchers have found something very exciting.
The Great Pyramid of Giza is thought to be the tomb of one of the earliest pharaohs of Egypt, King Khufu. More than 4,000 years after its construction, it's still receiving visitors.
It smells dust, essentially. Surprisingly, it's quite humid because there are many tourists visiting the place. There are even mice, actually. We had some issues with the telescopes because mice were visiting them and eating some cables. There is some life inside.
That's Sébastien Procureur. He's a chief physicist on a project called Scan Pyramids. Launched in 2015, Scan Pyramids is a collaboration between institutions in Egypt, France and Japan, all trying to gain a deeper understanding of the Great Pyramid.
The idea was to check for the internal structure of the pyramid with density measurement, with the idea to check whether there is any room, cavities, hole, corridor, whatever, which could be inside the pyramid, but which were still not found.
Inside the pyramid, there are 3 main chambers that we know about: the King's Chamber, the Queen's Chamber, and an underground chamber that appears unfinished. There's also a 47-metre-long corridor leading to the King's Chamber called the Grand Gallery. To investigate whether there were any other chambers inside the pyramid, the Scan Pyramids team used an imaging technique called cosmic muography.
In photography, you use a photon, that is the light, to make an image of an object. But of course, you have only the external image of this object. You don't see inside. Muography, on the other hand, use muon particles. And the advantage is that it can really see the inside of the structures.
It works by the detection of muons, elemental particles produced by the interaction between the atmosphere and other particles called cosmic rays. The muons make it down to Earth and are highly penetrating. They can go through tens or hundreds of meters of solid rock, depending on their energy. Scientists can use the variable penetration of muons to figure out the density of a structure. It's like a race. At the start of a race, you know how many people are taking part, and by looking at how many people make it to the finish line...
And just making the ratio of these two numbers, you have an estimate of the difficulty of the race. With muons, it's exactly the same. That is, some of the muons will cross the whole pyramid, but some others will stop just because they didn't have enough energy to cross the whole pyramid. So just by counting the number of muons crossing the pyramid in a given direction, you have an estimate of the difficulty of the race, that is an estimate of thickness and then the density.
The teams set up muon detectors inside and outside the pyramid at different locations, and by taking what are essentially cosmic muon photographs at different angles, they built up a picture of what the internal structure is like, including where some conspicuously empty areas were in what should have been solid rock.
With the muography measurements, we were able to find 3 different cavities. So a first cavity was found on the northeast edge. Then a second cavity was found just on the north face, just behind what we call the chevron zone. And a third cavity, which is the biggest, was found above the Grand Gallery, so it was called the Big Void. The length is estimated to be about 30 meters, between 30 and 40 meters long. So it's several hundreds of cubic meters in total.
Sebastian and the team are confident that what they found is not just a deformation in the rock or smaller stones that have crumbled, due to the careful way that they imaged the pyramid from multiple locations. They used simulations to help guide where they should put the detectors.
And it turned out that the position that the simulation gave as the best position was let's call it the restroom of the camels. So so we had to discuss with the camels to
And there's other evidence that what they found is a real secret chamber.
What is also very intriguing and cannot be considered as a coincidence is that all the structures I was talking about, so all the rooms and corridors, they are placed in the same plane in the pyramid, so it's a north-south plane, which is slightly shifted with respect to its center. So the plane is 7 meters in the east direction. And it turns out that this big void is also placed in this special plane. So all this says that it cannot be a coincidence and there is really a big, significant void at this place.
I asked Sebastian if he thought there might be something inside the big void.
If there is a tomb, if there is some objects of any kind, even gold or whatever, I mean, we can imagine whatever. And actually, there are already several theories of what this void can be. One theory is that it might be the real tomb of the pharaoh. Another theory is that it was used as a storage place. There's an interesting theory also which says that it may be a second Grand Gallery. And in this theory, actually, the Grand Gallery was used to put the granite stones of the King's Chamber. Maybe a second Grand Gallery was required to put the highest stone of the King's Chamber.
So it may be that the big void was created as a necessary part of the construction of the pyramid, and Sebastian is confident that future scans with even newer techniques will help reveal more details of how this Great Pyramid was built. Also, one of the long-standing curiosities of Khufu's pyramid is that, unlike most other pyramids which are richly decorated with images and inscriptions telling stories about the life of the person buried there is virtually nothing on the walls of Khufu's pyramid. On top of that, it's completely empty of the objects we know people were often buried with, things like pottery and gold that they would need in the afterlife. This is no surprise, really, as tomb robbery was absolutely rampant in ancient times. But still, perhaps the big void and the other spaces they found represent untouched, undisturbed chambers, which themselves could hold the key to understanding more about the mysterious Khufu's reign.
How amazing. That was Sebastian Procureur. We are looking at how modern science is helping scientists to solve some of the mysteries of ancient Egypt.
And one of those mysteries concerns a long-lost city called Punt, which was hugely significant as a trading partner with the ancient Egyptian civilization. Unfortunately, while they wrote a lot about Punt, including poems and songs, the Egyptians didn't say exactly where it was. So archaeologists have hit a bit of a dead end trying to understand how that ancient trading route operated. Now, that might be about to change thanks to a breakthrough involving animals that the Egyptians kept as pets and went to Punt specially to purchase: baboons. They also mummified them, meaning specimens of those pet baboons exist in museums and, critically, still carry a chemical fingerprint of where they came from originally, putting Dartmouth College's Nate Dominey on the scent of where Punt might have been.
There are two mysteries, a mystery wrapped in a mystery, and the first involves baboons, because baboons have a very large distribution across sub-Saharan Africa. And generally, across Africa, baboons are disliked. You rarely see baboons in any kind of statuary or carving or any kind of handicraft. Egypt, however, is the big exception, because when you look at the entire arc of Egyptian history, you see that baboons have been revered. They've even been deified. They've been elevated into the pantheon of Egyptian gods. So it's really quite a striking reversal to the general patterns across sub-Saharan Africa. The puzzle for someone like me who studies primates is that baboons never lived in Egypt. The Holocene fossil record, which is the period of time of modern human habitation and agriculture and complex societies, is entirely devoid of any evidence of any primate whatsoever, let alone baboons.
Have we got physical specimens of baboons from that geography? Nevertheless, they must have encountered them because they deified them.
That's right. So we find baboons buried in human context. They were deliberately buried. The oldest evidence looks like it might have been a zoo. One young baboon is buried with a young person about age 12 or 13, suggesting status as a pet. And then at later periods, we get royal mummification, where the animals were actually wrapped in linens and interred in royal tombs in the Valley of the Kings. And then in a still later period, during the Roman and Greek period, we get the period of animal cults, where baboons and many other animals were mummified on a practically industrial scale. You get tens of thousands of animals being mummified during that period.
So therefore, if you've got evidence of these animals being deified in that particular geography, you've got evidence of specimens of them being brought to that geography, but there's no evidence that they were naturally there. This argues that any baboons that are there were brought there by human activity, and therefore the question must be from where?
Precisely. And the Egyptians, they have written records of importing baboons into Egypt. They have paintings and reliefs on their temple walls and tombs showing the importation of baboons from a distant place. And they tell us that place. The place was Punt. And that's the other mystery, is where was Punt?
Oh, so there's lots of references to a place, but that place no longer exists and we don't know where it is.
Right. Historians have argued about Punt because it was terribly important, because the Egyptians typically, when they wanted resources, they might go to war to get those resources. We know the Egyptians went to war with the Nubians. They went to war with the Hittites. But with the Puntites, they sent emissaries, they sent ambassadors, they sent diplomats. This was a very important trading partner for the ancient Egyptians, primarily because the Puntites produced very valuable incense that the Egyptians used for religious purposes. So the Egyptians were highly motivated to travel great distances to go to Punt for these exotic luxury goods, including baboons.
So how can you use our knowledge of baboons to work out where Punt is then?
Baboons are a really great animal system for this question, because baboons drink water every day, and the water in your environment reflects the rainfall, and the chemical composition of water evaporates at different rates. And so when animals are drinking water on the landscape, they incorporate those chemical signatures, the oxygen stable isotopes in the water, and it incorporates that into their bones and in their teeth and in their hair. And so you get this geographic fingerprint of where an animal's been living based on the kind of water and food it's been ingesting.
But what about if you do what you said, which is that there's evidence that there were animals being held in captivity in Egypt? Will you not then see the signature of Egypt rather than the signature of where the animal came from written into those ratios?
Yes, that was a great risk of the project, is that long-term captivity would produce a geographic signature associated with living in captivity in Egypt. And so we use different tissues, hair, bone, teeth, which integrate drinking water and food over different intervals of the animal's life. And a large number of animals, for example, the baboons that we studied that were at the Petrie Museum in London, those animals uniformly showed us a signature that was consistent with a lifetime living in Egypt. And so we think the Egyptians may have been, they may have had a husbandry program. They may have been breeding them in captivity. But we got very lucky. There was one animal at the British Museum that showed us a signature in the teeth that showed us a distinctly foreign signature. It was unambiguously non-Egyptian.
So in order to work out where Punt must have been, are you reasoning then that if you triangulate the origins as written down in the teeth and other specimens of these baboons, that Punt must be somewhere relatively equidistant from these places or close to where a lot of these animals were originating from? That would give you a narrowed geography for where Punt was likely to be.
Exactly. So the Egyptians tell us that Punt was east and south of Egypt, and they tell us that you could reach it by land or sea. Problem is that east and south of Egypt, still a lot of open possibilities. And so what we can do is we can take baboons living in all of those competing areas, Somalia, Eritrea, Ethiopia, Yemen, Sudan, Uganda. We can take baboons living in those areas now, and we can look at their chemical signatures and create a chemical map, if you will, of that region. And so then we can match the mummified specimens that are present at the British Museum to populations in those areas. And the great thing about our analysis is we could definitively rule out some places, and we showed a very strong match to animals living in Eritrea and Somalia today.
That would be, therefore, the most likely place where the animals were sourced from. But do you not just think that it could just be that was a good hunting ground and they were transported from there to wherever Punt was?
That's right. Punt was both a kingdom and an emporium on the coast. So there was a market town or port. And so we think the Egyptians would have pulled their ships up to the port, and they may have purchased or traded for animals that were there in the port city. But the animals may have been sourced from farther inland, and that makes sense. We think the Puntites knew their market, they knew their consumers, and so they would have gathered animals from farther inland and brought them to this central entrepot for trade with the Egyptians.
So how much narrower is the search for punt now in the wake of what you've done?
Much narrower. For 150 years, scholars have been debating about the possibility of the Arabian Peninsula. So Yemen has always been a strong contender for the location of punt. Some authors have put it in Mozambique or Uganda. We can rule those places out, and we can say definitively that it was somewhere in Africa, on the Horn of Africa, probably in Eritrea and Somalia. Those two places, we can't distinguish between those two places, which are the two contending places that most scholars agree on.
And is there any way to nail it well and truly?
Yes, I think so. I think if we can turn to ancient DNA, maybe turn to some of the other tissues that were coming out of punt, if they all start to point in the same place and corroborate each other, then we'll really have something. And obviously archaeology is where we need to go. It would be nice to dig in some of those areas, and if we can find the remains of these ancient places, that'd be the clincher.
It's like an episode of Indiana Jones, isn't it? That was Nate Dominy on the trail of the lost city of Punt, which we now know, thanks to him, is somewhere south of Egypt, and he recently published those results in the journal eLife.
Also south of ancient Egypt was a land called Nubia, and archaeologists have made a surprising finding there too. Signs that the Nubians were being exposed to antibiotics. Human bones recovered from the area glow green under UV light, which is due to tetracycline, an antibiotic we use today, embedded in the bone. The University of Cambridge's Tamsin O'Connell is an archaeological scientist, and she's with us to explain the story. So Tamsin, first of all, where on earth were ancient Nubians getting tetracycline from?
Well, either they were getting it from things that they were eating or drinking, and we think it's an accidental product that gets in there. So if they're consuming something like beer or bread made from grain that might have tetracycline in it, then that gets incorporated into their bones, and a long time later we get to see it glowing under UV light.
Why might there be tetracycline in grains?
Tetracycline is a naturally occurring product of fungi, and it occurs naturally when fungi grow under certain conditions. And that can be when grain is stored in slightly damp environment. So if they're having a wheat harvest and then putting it in a big grain storage area, and you have water that's kind of coming up and going down in the ground, then that could make the grain at the bottom go slightly moldy. It would still be good enough to eat, but it might contain kind of trace levels of tetracycline.
I see. So if they then use that wheat to make beer or bread, then they're going to be accidentally eating tetracycline. So then how does the tetracycline get from being eaten as bread to being incorporated into bone?
So tetracycline, it's quite a big molecule, and it's got a ring structure in it of carbon chains, and its structure loves to bond to calcium. And there's a lot of calcium in your bones. And so as bones are growing, as this calcium phosphate, which is in your bones, is being laid down, if there's something in your bloodstream that likes to bond to it, then it will just be kind of stuck in there and it will hang around forever.
So does that mean that if you've ever taken tetracycline, then you have some glowing bones?
Yes, pretty well. So the bits of your bones that were being remade, remodeled, turned over when you were taking tetracycline or any similar sort of antibiotic, that includes things like doxycycline, which is an anti-malarial, those bits of your bones will glow if you could get them out and look at them under UV light.
So maybe try to avoid that for now then. How do we know, though, that the tetracycline got into the bone because it was incorporated by the bone owner throughout their lifetime, rather than it got into the bone through some sort of contamination, because it has been thousands of years?
That is a really good question. And whenever we find anything in archaeological samples, we have to question whether or not it's naturally occurring, if it came in during the individual's lifetime, or if it came in later on. And the shape of the glowing lines within the bones tells us that it looks like it's sort of on the growing face of a bone cell being formed, rather than percolating in from contamination later on.
I see. So it's sort of just in the right place to mean, all right, this got in there because it was being incorporated officially as part of bone rather than randomly slapped on afterwards.
Yes, it's worth saying that tetracycline is used as a label in modern day studies of bone turnover and bone remodeling. So we know an awful lot about what it should look like when it's being taken up by living and growing bone. And so comparing the archaeological bones and the patterning we see there with what we know we see in modern bones when tetracycline is being used as a bone label gives us confidence that it is being laid down when these people were alive.
And do you think that it could have had some sort of health benefits? Is there enough tetracycline in there that it could have had a benefit to the person consuming it?
So having low-grade antibiotics in your diet could have some benefit if people were having, bacterial infections. But we really can't say that they knew that it was of health benefit to them. Although we do know from the texts that beer dregs are often included as an ingredient in medical prescriptions from around about this time, 4,000 years ago. And so it's possible that they knew that there were some good things that they were accidentally getting in beer and bread.
So do we have any other evidence of ancient Egyptians or other civilizations taking antibiotics possibly on purpose?
Not that they're taking it on purpose, but we can see tetracycline in bones from other populations. So it's been found in people who were living in Herculaneum at the time of the eruption of Vesuvius. I would speculate that any population where grain has been stored and could have got mouldy would be able to see some tetracycline in there.
Sounds vaguely disgusting, so I think I'll stick with the regular pill form for now. But thanks very much. That was Tamsin O'Connell. And thanks to our other guests this week, Tom Hyam, Sebastian Procureur and Nate Dominey.
And let's finish this week with an electrifying question of the week. And Katie Hayley is leading the charge on this one for Michael.
Why can't batteries such as AA or AAA size be recharged? What's the difference between regular batteries and rechargeables, especially lithium ones? Is this a big battery conspiracy to sell more batteries, or are there valid reasons?
A big battery conspiracy, huh? Well, here are three scientists who can root out this recharging riddle. Gareth Hines from the National Physical Laboratory, and David Hall and Dee Wrinkle from Cambridge University. Gareth first.
There are two types of battery: primary cells, which are designed for single use, and secondary cells, which are rechargeable.
Every single battery in the world consists of two electrodes, one we call the positive, the other is the negative, separated by some sort of an electrolyte solution, that is, a salt dissolved in a solvent.
When a battery is discharged, electrochemical reactions occur at each electrode, converting chemical reactants to products and generating electricity.
However, there are many choices for the electrodes and for the salts and solvents. Only some of these choices can be recharged, which scientists call secondary cells. But for others, like most AA and AAA batteries, using the stored energy is a one-way street.
Whether a battery is rechargeable or not depends on what the positive and negative electrodes are made of. The most common AA and AAA batteries are called alkaline batteries, and these have zinc metal and manganese dioxide electrodes. When you use the battery, the zinc metal is eaten up and you form zinc oxide. Unfortunately, this reaction is irreversible, which means that you cannot get the zinc metal back if you recharge the battery.
In a secondary cell, the electrochemical reactions are reversible. For example, in a lithium-ion battery, the very small lithium ions can easily insert into both electrode materials, usually graphite and a mixed metal oxide. So the electrochemical reactions work equally well in both directions. This means that the battery can be charged and discharged many times.
There are also rechargeable AA or AAA batteries, such as the nickel metal hydride battery. The reactions in this type of battery are reversible, which means that you can recharge the battery and use it again.
So this is not a conspiracy by battery manufacturers. Primary cells are inherently limited to a single discharge, while secondary cells are not.
Ultimately, when choosing a battery to use, one has to consider the energy needs of the device. For example, a cordless drill needs lots of power in short bursts, which takes a higher voltage battery. But a smoke detector uses very small amounts of energy over a long period of time, and so it needs low voltage batteries, such as your standard AA or AAAs.
I just need to remember to check which batteries are the rechargeable ones before I put them in the charging station. Thanks Gareth, Dee and David. From batteries to boredom now, because next time we're boring into this question from Douglas.
Do animals get bored eating the same thing all the time? Like sheep, do they get bored of one type of grass?
Well, that's certainly food for thought. And if you can help, come join the debate on our forum, nakedscientist.com/forum. Or if you'd like to ask us a question, we're on chris@thenakedscientist.com or use the web form at thenakedscientist.com/question.
And there we must leave it for this week on The Naked Scientist. Thanks to Eva who put the programme together, and do be sure to tune in at the same time next week, because 10 years on from the earthquake that triggered the Fukushima disaster, we're looking at the science of tsunamis and earthquakes. The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education. It's supported by Rolls-Royce. Until next time, goodbye.